In this video, we'll look at right-angled triangle trigonometry. So we'll start with a right-angled triangle, and we have to consider where our angle will be. It could be either down the bottom here or up the top. If we place it here, that will affect the names of the sides. The three names: the hypotenuse is always going to be the diagonal side, that's the longest side, across from the right angle. Now the opposite and the adjacent sides will depend on the angle. Now if my angle is down here, then the opposite side will be that side there, and the adjacent side will be here. If we were to move the angle and have theta up there, then we'd have to swap the opposite and the adjacent. This side now is across from the angle, so we are opposite here and we are adjacent here. So for triangle ABC, the hypotenuse would be the longest side, which is side BC. The opposite side, well, I haven't got the angle in place yet. Let's put the angle here. So the opposite side would now be that length across there, which is length AB, and the adjacent side would be this length here, which would be length AC. Our next example, triangle KLM, the hypotenuse, always the easy one to spot, is the one across from the right angle, so K to M. Opposite side, here's the angle, so that side is opposite, so that is side KL. And the other side, the adjacent side, must be L to M. So we now have some trigonometric ratios to consider. We have the first ratio is known as the sine. Now the sine of the angle, theta, is equal to the opposite length divided by the hypotenuse. And we write the sine of theta, sin theta, although we pronounce it sine theta. The next ratio is actually dividing the adjacent length by the hypotenuse, and that is known as the cosine. And we write cos theta, and we pronounce it cos theta. The third ratio we will work with is the opposite divided by the adjacent, and that is known as the tangent, and we write that as tan theta. So our three ratios, these ratios here, all involve angle theta in the right angle triangle and dividing two lengths to get a ratio. Now, trigonometry is based on the fact that for any given angle, suppose we had angle theta down here, then the ratio of two sides remains the same, no matter how large the triangle is. So we've got this length divided by that length would be the same as this length here divided by that length there. And we know that using what we've studied before in terms of similar triangles. Let's demonstrate that using Geometer Sketchpad. So here we have a triangle with an angle of 30 degrees and a length of 10 units across the bottom. And I've worked out the tan of theta, the ratio being opposite on adjacent. So the opposite length is A to C, and the adjacent length is A to B. Divide those two and I get a ratio of 0.58. Now, if I were to move point C, then the ratio of that length on that length there should be the same. And if I were to change the position of this point here, the ratio remains 0.58. So if I measure this length and measure this length down here, now if I were to divide these two, that's the opposite and that's the adjacent, I should end up with 0.58. So if I measure, calculate, and if I divide that one by that one there, we can see we get the same result of 0.58. And no matter where I move point E, these two lengths here are changing, but the ratio remains the same. Okay? And we know that from our work on similar triangles. So the tangent of 30 is always going to equal that same ratio of 0.58. Now in this triangle here we have three lengths, 3, 4 and 5, and an angle of theta. So if I were to work out the three trig ratios, we have the first one, sine theta, is equal to, well, here's the angle, that length is opposite, so it's 4 divided by, and that length there is the hypotenuse, so 4 on 5. The cosine, so cos theta, is equal to the adjacent, which is 3, divided by the hypotenuse, which is still 5. And the tangent, so tan theta, is equal to the opposite divided by the adjacent, so 4 divided by 3. So they are my three trig ratios. So in summary, here are my ratios. We have the sine of theta is opposite on hypotenuse. We have the cosine of theta adjacent on hypotenuse, and the tangent of theta is opposite on adjacent. And we have a technique here for remembering those three ratios, so SOHCAHTOA. So sine, cosine, and tangent. So SOHCAHTOA is what you would use to remember the ratios. Now we can use these ratios to work out unknown lengths in right angle triangles. So in this case we have an angle of 35 degrees, and we have the opposite length here, and we've got the hypotenuse there. So the trig ratio we'll use there will be the sine. So I know the sine of 35 degrees is equal to opposite, which is A, and the hypotenuse, which is 6. That's one equation, one unknown, which we can solve. So if I move 6 across the other side, I'll get A equals 6 times by the sine of 35. Now, the sine of 35, that ratio is stored in your calculator. So all we do is make sure we are working in degrees. That angle there must be in degrees. And we can press 6 sine 35 and we'll get our answer. So 6 and then sine of 35 will give me an answer of 3.44 to decimal places. Next example, we have once again an angle and two lengths, one of which we don't know. So in this case, this length here is the adjacent, this length here is the hypotenuse, and that trig ratio will be the cosine. So the cosine of 32 degrees is equal to the adjacent on the hypotenuse. Once again, we can make f the subject by moving the point 346 across the other side. Then it's a simple matter of using the calculator, because once again that ratio there of cos 32 is saved in the calculator. And we get an answer of 0.29. Now our third and final example, we have the angle of 5 degrees. Now this length here is adjacent, this length here is the opposite. Notice there is no hypotenuse. The trig ratio without the hypotenuse is the tangent. So we'll use the tan of theta. So in this case, tan of 5 degrees is equal to, now it's the opposite on the adjacent. So rearrange that equation there. The p will multiply with the tan 5. Now that tan 5 will divide into the 120. And once again, simply using the calculator, we'll get our result. All right, so we get 1,371.61. Okay, so that's a little intro into working with trigonometry with right angle triangles, and we've looked at how to work out missing lengths using these three trig ratios.